Okay, exam 2, page 1. The first part is use the definition of derivative. Let's highlight that. Definition of derivative to prove d over dx of square root of x minus 4 is equal to 1 over 2 square root of 2x. Remember the definition of derivative is limit of h approaching to 0 f plus x, minus f of x over h. Your definition derivative is limit of fx plus h minus f of x over h as h approaches 0. That's your definition of derivative. So here you can just plug in your values. So your f of x is square root x minus 4. So you can plug that into these values. So then you'd have the limit h approaching to 0. You'd have square root of x plus h minus 4 minus your f of x, which is just x plus 1 over h. This is square root of x plus h minus 4 because of fx plus h. So if you have f of 2, that would be square root 2 minus 4, which is just square root over 2. So in this case, we put fx plus h. We plug this value, x plus h, into any x value of the original function. That's why we have square root x plus h minus 4. Okay, so what we do here, like always, to get rid of the radical, we times it. We times it. So we have x. We have square root of x plus h minus 4. You use the opposite sign. So if this is negative, you use positive. Square root of x minus 4 over the same thing. Square root x plus h minus 4 plus square root x minus 4. Oops, get rid of the parentheses. This would cancel out both of the square roots on top. So now you're left with x. I'm really messing this up. So you're left with x plus h minus x plus h. That's because both of these would cancel out. The square roots would cancel out. So then you're just left with this. You're left with x plus h minus 4 minus x plus 4. Yeah, or actually, take that back actually. You're looking at this one. So this, either way, both square roots would cancel out, so you're left with x plus h minus 4 plus what's inside, x minus 4. No, I'm doing this wrong again, my bad. So this will be this one, so it'll be plus. This should be negative. Yep, okay. So as the square roots cancel out, you're left with x plus h minus 4 minus x plus 4 times h times this one. So you'd have h times square root of x plus h minus 4 plus square root of x minus 4. So now you simplify. Don't forget to always carry your limit. So then you bring the limit over again. So you'd have the limit of h approaching to 0. So in this case, I really messed this up. Okay. So in this case, you cancel out the terms on the top. So x minus x just cancels out. Negative 4 plus 4 cancel out. So all you're left with is h. So you'd have h over h. The same thing again. Square root of x plus h minus 4 plus square root of x minus 4. Here you can cancel out like terms since they're both multiplying. Because this is just h times 1. So you cancel out both h, don't forget to carry limit. You have h equal to 0. You have 1 over square root x plus h minus 4 plus square root of x minus 4. In this case, now you can apply the limit. So then we'll continue upward. So this goes up. So you apply the limit. After you apply the limit, you don't need to carry this. So you can just write square root of x plus 0, because for every h you plug in 0, minus 4 plus square root of x minus 4. You're left with over 1. So simplify this even further. You're just going to have x minus 4 plus square root of x minus 4 over 1. This is what you're left with, and then these two can add up together, so this would just be 1 over 2 square root x minus 4, since you're adding both of them. So this is your definition derivative after that. So this does prove that d over dx of square root x minus 4 equals 1 over 2 times x square root of x minus 4. And this is a complicated process, but what you just need to remember is that you just need to follow this rule. You need to follow this definition, okay? And then after this, you can just plug in the values of your x plus h into your original function, and you always carry the h and the limit. And to get rid of whatever you have, like a square root, you just times it by the reciprocal. And then those should just cancel out the square roots. And then you combine the like terms, and then you cancel out terms again. Then you just apply the limit. It's a long process, but it does take practice, so don't beat yourself up. The next question is find the equation of the tangent line at x equals 5 for square root of x minus 4. So in this case, what we first have to do, so we have f of x equals square root of x minus 4. So that's our given. We need to find the tangent line. So first we need to do is we'll find the derivative. So the derivative is, this would be 2 over square root of x minus 4 over 1. This is the derivative because we'll simplify this even further. We'll take this as, let's say, square root of x, okay? So this is our original function. If we rewrite this, this can be rewritten as x to the 1/2. And if you find the derivative of that, you times 1/2 to x, so you're left with 1/2 x, and you minus 1. So you have x to the 1/2 minus 1. First you times 1/2 to this side, so you have 1/2 x, so, and then you're left with 1/2 minus 1, so 1 times 2 over 2. Well, I think I've complicated this. Let me rephrase this again, just so that it's clear. So to write the derivative of a square root function, you can write the original function as just square root of x. This is also rewritten as x to the 1/2. And to find the derivative, you times the exponent to the front minus 1. So in this case, we have x 1/2, we times 1/2, and to the front we have 1/2 x. Our next step is to minus 1. So 1/2 minus 1 times both by 2 to get common denominator. You're left with 1/2 minus 2 over 2, which is negative 1/2. So after finding that, your derivative would be 1/2 x to the negative 1/2. So any negative exponent, you write into a fraction form. So in this case, you would have 1 over 2 to the x of 1/2. Because to get this negative out of the way, this has to come into a fraction form. So this negative will turn into positive once it's in the denominator. And so we have this equation, which then can be rewritten back into the square root function. So we have 1 over 2 to the square root of x. That's how you do that. And then the same basis as for this one. So we'll expand it out for me. So our original function is square root of x minus 4. We can rewrite that into the exponential form. So we have x minus 4 to the 1/2. We'll find the derivative again. So this would be 1/2 times x minus 4 to the 1/2 minus 1. And this would be again 1/2 times x minus 4, which is negative 1/2. Now you can rewrite this back into square root form. So you have 1/2 times square root of x minus 4. Actually, no, I'm not going to do that yet. So you have, remember, to get this negative exponent out of the way, you can rewrite this as a fraction. So you have 1 over x minus 4 to the 1/2. Now this can be simplified back down again. So you're going to have 1/2 times 1 over the square root of x minus 4, which then again simplifies as 1 over 2 to the square root of x minus 4, which is the derivative. I know it's a little hard to see, but try and work with me here. Okay. So now that you've found your derivative, okay, I think I want to step further because we haven't found out what x is. No, okay. Let's see. Okay, first you find derivative. Okay, that's x squared. Now you can plug in 5 since that's your given. So your given is x equals 5, so you plug this into the equation. So f prime of 5 would be 1 over 2 to the square root of 5 minus 4. This equals to 1 over 2 over 1, so the square root of 1, which is 1, so then you're 1/2. So f prime of 5 is equal to 1/2. So we keep that in mind, so we can put this on the side to create more room. So f prime of 5 is equal to 1/2. And this would be our M10, which in other words is our slope, so keep that in mind. This is our slope. So the derivative of the function would be the slope. Get that out of the way. Now to find our y value, set y value, we plug in 5 into the original function. So we have f of 5 for the square root of x. For the square root of x minus 4. So we plug it in. So we have square root of 5 minus 4, which is just 1 again. Square root of 1, which is just 1. So f of 5 is equal to 1. So this is our first y value, and this is our slope. Now we can plug this into point slope form. So we have a point and we have a slope, and we can put that into the point slope form, which is just y minus our given value, which is 1, is equal to the slope, which is 1/2 of x minus 5, since that's our given value. So now we can just simplify this function. So we have y minus 1 equals 1/2 x minus 5 over 2. So To isolate the y, we add 1, so y equals 1/2 x minus 5 over 2 plus 1. To find the common denominator of that, we should 5 over 2 plus 1 over 1. Both common denominators 2, so then 2 over 2. This is negative. So we have negative 5 over 2 plus 2 over 2, which becomes negative 3 over 2. So this is our y value. So simplifying this, we have y equals 1/2 x. Well, it became ugly. Y equals 1/2 x minus 3 over 2. That is how you find the tangent line. What you first do is you look at the original function, you find the derivative to get the slope, and then you find the first y value by plugging in your given x value to the original function, which gives you 1. And then from 1/2 and 1, you can put those values into the point slope formula, which is y minus your y, the found y, equals m, which is your slope, times x minus 5, which is your given x.